So I'm recording this video because Chloe forgot to edit and upload one, but if someone else makes a video for someone, then they don't get punished. So yeah, I'm gonna upload this video, and then Chloe can post video, I don't know, Monday or something. I don't know. Good luck. Go for it. Roll the intro. We don't have an intro. Hello everybody. Let's get started, because today I'm going to teach you about math, because math is wonderful and I love it. So let's get started. And what I'm going to teach you today is one of my all-time #1 favorite proofs. And it's less of a proof really, and more of a warning. I'm going to talk about proofs today. And the proof I'm going to show you is a warning. A warning to make sure that your hypotheses that you are basing your proofs on make sense. We want to prove that the largest integer, so large integer being any like positive whole numbers, so like 5 is an integer or 7 is an integer, etc. And this camera's on my bed right now, so it's kind of shaky. I apologize. Prove the largest integer is 1. So we're going to show you today, at least I'm going to show you today, I'm using the royal we, but I'm going to show you today that 1 is the biggest integer there is. And let's get started. So, proof. So we're going to start off by saying, okay, our original hypothesis is that, well, pick a random letter to represent a number, right? I don't know, if you pick the letter M, for instance, M be the largest integer. So we have, this candidate. We have this candidate for the largest integer, right? And whatever that might be, right? M is going to be the largest integer. Now, here's the thing. Since M is the largest integer, that means that if I square it, right? M squared must be, because M is the largest, M squared has to either be smaller than or possibly equal to M. Right? Because M is the biggest thing. So if I square the biggest thing, whatever that is has to be either smaller or equal to. Now, you think, oh, but everything squared is always bigger than. Well, not the case, right? Because we look at an example, for instance. Right? If I look at an example, I say, okay, well, what is 1/2 squared? Well, that just gives you a quarter. And a quarter, right, is actually smaller than a half. So yeah, that's totally fine. You can have a square that is smaller than the original number. That's totally cool. Absolutely fine, we can do that. And so, since M squared has to be less than or equal to M, but M is an integer, right? We only have 2 candidates that this would work for, right? Our 2 candidates that have this be true, right? Because first of all negative numbers don't work, because any negative number squared gives you a positive number, and positive numbers are automatically larger than negative numbers. So our 2 candidates, M is either equal to 0, or, and this is an exclusive or, M is equal to 1. Let me make sure that's on the shot. Yeah, it's on the shot. Now, here's the thing though, right? We know that 1 is bigger than 0. And if you want to know the proof of that, that's the Zermelo-Fraenkel axioms and sort of the way the integers are constructed, but I'm not going to get into that here. And thus, M is equal to 1, and therefore 1 is the biggest integer. Boom. I've just showed that 1, that's a little bit off the screen. I'll do that over here. Therefore, I have just shown that now 1 is the biggest integer. Done. Right there. Look at this. Perfect. Perfection. Actually, no. This is not perfection. And this is what I was talking about when I'm talking about making sure your hypotheses are right. Because there's an issue with this proof. And the issue is right at the beginning. This right here. We've made an assumption there, right at the beginning, right at the start of our proof, that there is a largest integer. And that assumption has led us to a conclusion that doesn't work. And so, when you're working in mathematics, always be mindful of what your hypotheses are and what the consequences of those hypotheses, what they are, right? Because this is an issue. This is problematic. So, there you go. One of the coolest proofs that it's not actually a proof. And yeah. So, good luck out there. Bye.